All right, so really quickly, I want to show us all, just in case, because because of the whole Omicron thing, more and more people are being exposed and have to quarantine. I just want to show us on our Schoology just where resources are available. So if you go to our class, textbook is in the important resources folder. Here in our Chapter 7 folder, there's another folder here at the top that says Chapter 7 Notes and Videos. So what I write on the board and what I say in class, I'm recording, and the links for those, I need to put the 7.2 notes up there. I'll make a note for myself. But every day I put up the notes and the videos for our lessons. So if you're out, you can always go into that folder and see what we've done in class while you were gone. So that's the way you would keep yourself up to date. And that's the same if you're absent for whatever reason. You can always go to that folder and get the notes and the videos for the lessons. And then, of course, the homework is available in the Schoology folder. So today, power to a power assignment. This is what we're doing today. So I just wanted to make sure that to show everybody that those resources are available. And I'm going to make myself a note to post the 7.2 notes. The 7.2 videos up there. I just need to post the notes. 2 notes. Algebra 1. Okay. And I'll get that done today. All right, so let's talk about a power to a power now. So I want to do what we've done for our other exponent rules, and we'll look at some examples. So let's say we have x to the 5th, and we want to square that. Now the key piece of information about exponent rules is that when we raise something to a power, it means we're multiplying it by itself that many times. So x to the 5th squared means that we're doing x to the 5th times x to the 5th. We're multiplying x to the 5th by itself 2 times. Well, now we're just multiplying 2 things with an exponent. And what do we do when we multiply 2 things with the exponent? What do we do with the exponents? We add. So this is x to the 10th. And if we had x squared to the 3rd power, same thing. That means multiply x squared by itself 3 times. X squared times x squared times x squared. Well, now we're just multiplying things with the exponents. So we add the exponents. This is x to the 2 plus 2 plus 2, which is 6. All right, can we kind of see what's going on there? Let's look at one more just to be sure. X to the 3rd to the 4th power. Well, that means x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. Well, we have 4 things with the same base. We're multiplying them together. So we add the exponents. That's 3 plus 3 plus 3 plus 3, which is 12. So when we have a power to a power, what are we doing to the exponents? We're multiplying. That's going to be our rule for a power to a power. We multiply the exponents. And the way we write that in symbols is a to the m raised to the n power is a to the m times n. And I don't know why, but in pretty much every textbook I've ever seen, when we talk about exponents, for these exponent rules, they use m and n. I don't know why that is. So let's look at a few more examples. This is not super complicated. Um, 5 to the 4th squared. What's that going to be? 5 to the 8th. We multiply 4 times 2. How about x to the 3rd to the 5th? X to the 15th. We just multiply. Let's make it a little trickier here. Need to remember something here. M to the 3 halves times 3. Sorry, 3 halves to the 3rd power. Well, we need to remember m to the 3 halves times 3, and we can think of 3 as 3 over 1. And what do we do when we multiply fractions? We multiply straight across. So this is going to be m to the 9 halves. 3 times 3 is 9. 2 times 1 is 2. So how about y to the 1/3 raised to the 2/5 power. It's a power to a power. Doesn't matter if they're fractions. The rule doesn't change. So this is y to the 1/3 times 2/5. So that would be y, not x, to the 2/15. And we're done. Now if we can reduce the fraction, usually we would reduce the fraction. All right, let's look at one more example that's a little trickier when we have a little more stuff going on. Oh, there's a negative exponent, so we need to think about that for a second. H to the 4th to the -3 power. So we need to remember PEMDAS here. What does PEMDAS tell us to do first? We don't have all the stuff inside the parentheses is simplified, so we need to do exponents first. We need to deal with this h to the 4th to the -3rd power. So we're going to do this first. So we're still following PEMDAS here. So exponents first. So this is going to equal h to the -2 times, we multiply the exponents, h to the -12. Well, now we have two things to the same base multiplied. So what do we do to the exponents? Now we add. So it's going to be h to the -14th. And when we simplify exponents, we don't want that negative exponent in the numerator. So we can think, oh, this is h to the -14 over 1. I'm going to flip that over and make the exponent positive. 1 over h to the 14th. So sometimes we have to use our rules, multiple of our different rules, to simplify a problem. All right, we good there? Power to a power, pretty easy rule. Next thing we're going to talk about is a product to a power. And we'll look at some examples first. So 2x to the third power. We're going to remember that 2x to the third power means 2x times itself 3 times. Well, that's 2x times 2x times 2x. And I can group the numbers and the variables together. So this is 2 times 2 times 2 times x times x times x. Well, 2 times 2 times 2 I can write as 2 to the third, and x times x times x I can write as x to the third. So what I've done here is raised each of these to the third power. It's kind of like it's being distributed. At 2 to the third we can write as 2 times 2 is 4 times 2 is 8 x to the third. And if we had something like x times y to the fifth power, we remember that's x times y times x times y. We have 5 of these. X times y times x times y times x times y. Well, how many x's do I have? 5. That's x to the fifth. How many y's do I have? 5. So in the end, what I've done is raise each of these to the power. So that's going to be our rule. So for our product to a power, we're going to raise each part to the power, and we multiply. Because this means multiplication. So it's sort of like that 3 is being distributed, sort of, but it's not really distributing, but it's kind of like distributing. All right, so let's look at a couple of examples of a product to a power. So we have 4xy squared to the third. Our rule is we're going to raise each part to the power and multiply. So this is going to be 4 to the third times x to the third times y squared to the third. Well, 4 to the third is 4 times 4 is 16. Times 4 is 64. X to the third just stays x to the third. Here I have a power to a power. What do I do with the exponents? Multiply. Power to a power, we multiply. Y to the sixth. Oops, I forgot my x to the third. There we go. All right, questions about what we did there? Let's look at one that's just a little more complicated, a little more stuff going on. B to the 1/3 to the 6th power times 2ab to the negative 1/4 to the 4th power. So PEMDAS tells us to do these exponents first. So b to the 1/3 to the 6th power. What do I do with the exponents? Multiply. So I get b to the 1/3 times 6 over 1. I'll just write it like that. Times, we'll deal with this in just a second. And here I'm going to raise each of these to the 4th power. So I get 2 to the 4th, a to the 4th, and b to the negative 1/4 to the 4th. I'm raising each part to the 4th power. Well, now let's deal with this. B to the 1/3 times 6 over 1, multiply straight across. B to the 6/3. We'll deal with that in just a second. 2 to the 4th. 2 times 2 is 4, times 2 is 16, times 2 is 32. A to the 4th. Negative 1/4 times 4 times 4 over 1. So I'm making all these steps, I'm combining or making all these steps explicit so we can see exactly what we're doing here. Well, what's 6 over 3? 6 divided by 3? 2. And I have 32a to the 4th. What's negative 1/4 times 4 over 1? Negative 1, because I have that negative. Well, here I have b squared and b to the negative 1. They're being multiplied. So what do I do with the exponents here? What operation do I do to them? We're multiplying things raised to an exponent, so we add. We multiply when it's a power to a power. Those two are kind of easy to mix up. So 2 plus negative 1 is 1. So this would be 32 a to the 4th, b to the 1, which is the same as saying 32a to the 4th times b. Either one of these would be fine. B to the 1st is just the same as b. All right, questions on what we did there? So our two rules for today. When we raise a power to a power, we multiply the exponents. When we raise a product to a power, we raise each part to the exponent. Those are our two big ideas for today. Yes? 2 times 2 is 4, times 2 is 8, times 2 is 16. Yes. I did my 2 to the 4th incorrectly. Thank you. Oops. And I need a 16 here. Because here we have b squared times b to the negative 1, so we add the exponents. 2 plus negative 1 is just 1. That was a good question. All right, other questions? Okay, our homework. Page, this is 7.3. Page 436. 10 through 66, every other even. So this would be like 10, I'm going to say 12, but we skip that one. 14, we skip that one, and we do 18, etc.